So welcome friends, I'm going to talk about overloading assignment operators in this lesson. And we talked about overloading an operator last time. So we overloaded a plus operator, and the plus operator we could have done, I showed two examples. One where we made it made it a non-member function, and the non-member function, it was convenient to make it a friend so that we could get access to the private members, even though the function definition or the implementation is outside the class. We made it a friend function. The other way we looked at is we could overload the operator plus as a member function, and when we make it a member function, we only need to pass one argument, which is on the right hand side, because the left hand side is passed implicitly. Now when we want to overload the assignment operator, there is one restriction, that we cannot make it a non-member. So the overloaded assignment operator has to be a member function, and the definition will be very simple. It will be very similar. So you can see here, if we go down, overload operator, it doesn't show here equal, but so overload operator equal, and then we will pass the right hand side as RHS. So it's very similar. Now actually I wanted to show you this, that we could actually just do a void operator equals. That's also fine. However, there are some limitations which we will see in a minute. Now I'll refactor this code, and in the simplest way what we have is we have a right hand side, and we know that right hand side, we know the value, and what we want to do is on the left hand side we have an existing object, so we want to create a new dynamic object. Now actually we don't have to create a new dynamic object, we only, in this case, we only need a value that exists. So we could do this, that this dot pointer, so we want to set the value of this to be same as the RHS. So we get the RHS, and this is an example where we are avoiding the mistake where we are just copying the pointers, because if we just copy the pointer, which the default assignment operator will do, which the compiler provides, it will be something like this: this dot pointer equals RHS dot pointer. That means now we have the object on the left hand side is pointing to the same object on as the right hand side, which is like we have seen before. This is what we want to avoid. So if we have assignment and we have the object on the left, let me clean it, and let me see, if we have this situation where the object on the right is pointing to the same object as on the object on the left, then we run into the same problem which we have seen before. So this is what we are trying to avoid, and that's why we created we don't want this. What we want is, we want this, we know that we have a pointer which already exists. We are assuming there is a new object already which the left hand side is pointing to, so we are copying the value from the right hand side. So this should work fine, and actually I'm going to also print here the overloaded assignment operator is called. Okay, so now let's do an assignment. So far we know that this looks like an assignment, but this is actually a copy constructor. So an object is returned which is copied onto object 3, and therefore we will not see. And let me run this code which we saw before. So you can see here um, the overloaded assignment operator is not called. And okay, so now the okay, so now what we want to do is actually we want to call the overloaded assignment operator. So we will just do this: object 3 is equal to object 2, and this is where the assignment operator, the overloaded assignment operator will be called. And then we will do object 3 dot print. And for now I'm going to do this so that we can keep this separate. I'm going to remove this example here and then just leave it as let's put 6 here. So we create 3 objects all together, then, and I'm also going to print object 3 dot print, and I print all those, and then we assign object 2 to object 3, and we print object 3 again. So object 3 should have a value 7. Okay, so we can see here we have 3 objects, and now you can see example class overloaded assignment operator is called. The new value for object 3 is now 7, which is what we expect, and so everything looks working fine. There are 2 problems, however. One, that we know that we could do chaining, which is we could do something like this normally with a assignment, but the way we have implemented our overloaded our assignment operator, it returns a void. And when I try to compile this code, we will get a compiler error saying that we are trying to call a method with a void value, or using the void value. Sorry. So let me compile this code. So you can see here, no match for operator equals, operand types are example and void. So first, we know that assignment always runs from right to left. So first of all, this thing happens, which means that object 2 is assigned to object 3. That function is called, which returns a void. And when after that we are again calling the assignment operator, and the left side is the object, example object, and the right side is a void, and that's why we are getting the error which says operand types are example and void. I hope you get the idea that this function call is returning a void, and when we again call the assignment operator here, the left side is an example object but the right side is a void, and that's why we are getting this issue. So this is called chaining, and to be able to do chaining, the standard definition for the assignment operator is, instead of returning a void, it returns a reference to the existing object, which is this object that is implicit. So now we are saying that instead of returning void, it's returning a reference to the same type of object so that we can chain it. And so what we have to add is return, and remember that this is a pointer, so we return star this, which means we are actually returning the object, but we are not returning the object, we are not copying the object, we are returning a reference to the object. So it may look a little complicated, but it's not. It's just we are returning a reference to the object which is on the left hand side. And now if I compile the code, you can see here on main object 1 it's working fine, and if I print object 1, it will also have the value 7, which is object 2 value is assigned to object 3, and object 3 value now will be assigned to object 1. And now you can see here both overloaded assignment operator is called twice, and both have 2 values, both have the same value 7. The last issue is that when we overload assignment operator, we could sometime, or someone could do something like this: object 1 equals object 1. Now this is called self assignment. Compiler is fine with this, but our code may sometimes run into issues, or in other words, actually it's we don't want to do anything if we are assigning the doing self assignment. So why do some work when we don't have to? So we could check if the right hand side and this are actually the same values or same objects. So for that we could write this: if this is equal to ampersand RHS. Now you know that RHS is a address, and or RHS is a reference, but RHS is an object. So we get the address of the right hand side, and then we compare it with this. This is also a pointer. So if both of them are same, which means both are the same objects having the same address, then we don't want to do anything. So one way is we could do this is if this is equal to RHS, then don't do anything. Or a better way is to say that we check if this is not equal to RHS, then only do all of this. Okay, and actually we still need to return this. So we do the assignment actually here. Okay, so we do the copying part. Whatever the copying is done, this is only done if these two objects are different. If they are same, we don't have to do any copying. We still have to return star this, and we still can print this value. So now if I run, let me copy this, comment this line here, and we will see that when I run this code, now I'm doing self assignment, but you can see here the int value is 6, and for object 3 remains 6, and object 1 remains 4, because we did self assignment but we didn't have to change the values. So everything is working fine here. So there's important things in whenever we overload assignment operator, we have to take care of two things. One is use this to avoid self assignment, and we return this to facilitate chaining of assignment operator, and that means we also have to return the object of same type instead of a void. Okay, that's all for this lesson. Thank you.